So hello everyone and welcome back to a brand new video, and in this video I'll be covering problem F, that is all possible digits from round A34. And sorry if my voice is breaking because I have a cold, so please excuse that. Now let's move on to the solution. But before we move on to the solution, I want to tell you guys about Newton School's coding contest. So Newton School organizes coding contest every month. You guys can solve some quality problems and also compete against top coders in the world. This will be a good opportunity to benchmark yourself where you guys are lying in respect to other students in India or around the world. And not only that, along with this, you can also win some cash prizes. You can win rewards up to rupees 90,000. You can also win scholarships up to rupees 20,000. And along with this, there will also be some job opportunities. So this month, the contest will be on 30th of November. It will be around 2.5 hours from 9 p.m. to 11:30 p.m. So do not forget to sign up. The link will be in the description. So do go and sign up from there. So we have been given a number x. X has n digits, where n can be up to 100, and it is written in base p, right? So what that means is that all the digits are from 0 up to p minus 1, right? So any digit is from 0 up to p minus 1, right? So we have something like x1, x2, x3, so on up to xn, right? And where every xi is from 0 up to p minus 1. Now we have been given an operation. In the operation, we can increase the value of x by 1. So we can do x is equal to x plus 1. And using this operation, we have to tell the minimum number of operations that are required to see all the digits from 0 to p minus 1 at some point of time, right? So we want to see all the digits from 0 up to p minus 1 at some point of time, and we want to answer the minimum number of operations that are required to do so. We can take an example to understand it. So let's say your number x is equal to 2302, and let's say its base is 5, so p is equal to 5. We will build a scene array, right? So we have a scene array. So it will have 5 digits. It will have 0, 1, 2, 3, and 4, right? Initially, we have seen 2, 3, and 0. So we'll mark 0, 2, and 3, right? Now to see 1 and 4, right? We have not seen 1 and 4. So to see 1 and 4, we will apply an operation on the number. So we have x equal to 2302. We apply an operation. We do 2302 plus 1. So we get 2303, right? So now we have seen 2, 3, and 0, but we have already marked 2, 3, and 0, right? So there is nothing new to mark in this operation. So this is the first operation. Then we do the operation again. We get 2303 plus 1. So we get 2304. Now we have seen 4, right? 4 was not previously marked. So we'll mark 4. Then we again do the operation. This is the second operation. Then we again do the operation. We get 2304 plus 1. And as number is in base 5, when we add 4 to 1, this will create a 0 and it will give us a carry, right? So you get 2310, right? So now we see a 1 as well. So you can now also mark the 1. So now we have seen all the digits from 0 to 4. So you can say it took us 3 operations, right? And this is our answer. So that is the problem. You have to give out the number of operations that are required to see all the numbers from 0 to p minus 1. So how can we do this? Now let's move on to the solution and the observations. Observation 1. Last digit is very important, right? Because if you think about it, the operation is x is equal to x plus 1. And if we write out x, we get x1, x2, x3, so on up to xn. And when you add 1, you are basically adding 1 to xn, right? So in every operation, xn will change. in every operation xn will change. But if you think about the numbers from x1 up to xn minus 1, numbers from x1 to xn minus 1, they will rarely change, right? They will only change when we get a carry. So most of the numbers from 0 up to p minus 1, 0 up to p minus 1, they will come from xn, right? So xn is responsible basically for creating numbers from 0 up to p minus 1, because all the numbers from x1 to xn minus 1, they will rarely change. They will only change when we get a carry, right? So that's why the last digit is very important. So we will build our answer around this last digit. So I will break the problem into two cases. Let's see them. So the case one is when last digit gives no carry, right? I can take an example for this. Let's say your value x is something like 102793. It is something like this, right? And your p is equal to 10. So if you build your scene array, you will get 0 1 2 3 4 5 6 7 8 9. 0 is seen, 1 is seen, 2 is seen, 3 is seen. This is your last digit, right? 3 is your last digit. And then your 7 is seen, and then your 9 is seen, right? So if you see here, all the numbers on the left side, are seen, right? So you will never need a carry from 9 to 0, right? Because you have already seen the numbers on the left side. You have seen 0 1 2. So why would you ever need a carry? So you will never need a carry to go from 9 to 0. Why would you go on the left side if you have already seen numbers? You are just wasting operations then, right? So in this case, you will never do a carry operation. So I will define two terms. First term is the left block, right? So it is basically contiguous block of seen elements to the left of last value, right? So if we see here, this is the last value. Let's try to build a contiguous block of seen elements, right? So we have seen 2, so it will also be in the block. We have seen 1 as well, so it will also be in the block. And if we see 0, it is also seen, so it will also be in the block. So your left block is ending at 0. It will end at 0, right? So you can say that if your left block ends at 0, that means all elements on left side are seen, right? And that means you will not need a carry. And if we look on the right side, we will define one more term. We will call it missing, right? Missing is the greatest element that we have not seen, right? So in the following example, the greatest element is 8. So this is the missing element. So we'll just start from the last value. We will do one operation to reach 4. Now we have seen 4. Then we again do one operation to reach 5. Now we have seen 5. Then we again do the operation, we reach 6. Then we again do the operation, we reach 7. Then we again do the operation and we reach 8, right? So it took us 5 operations. And now we have seen all the elements from 0 to 9, right? So in this case, the answer is just how much? Answer is just the missing element minus the last digit. This is just 8 in this case, right? The highest element is 8. So we have 8 and the last digit is 3, right? So this is just 8 minus 3. So the answer here is just 5 operations. That is the case when your left block ends at 0, right? When your left block ends at 0. Now let's move on to the second case when you need a carry. Alright, so let's move on to second case. So the second case is when your last digit gives a carry, right? So something like, let's say 709 and let's say 24, right? Something like this. This is X and your P is again equal to 10, right? So we make the scene array again. We get 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9, right? Currently we are at 3. This is the last digit. So this is not the last digit. Currently we are at 4. 4 is the last digit. And we have seen 7, we have seen 0, we have seen 9, we have seen 2, and we have seen 4, right? So now if you see on the left side, we have some missing elements, right? We have not seen 1 and we have not seen 3. So we first have to go to 9 and then we need a carry. Then after taking a carry, we need to look for these 1 and 3, right? That is why we need a carry in this case. So if you see the left block here, left block starts at 4. But we cannot extend the left block, right? Because 3 is not seen. So we cannot extend the left block to the left side. So in this case, left block just ends at 4. So what you will do is, you will start from the last digit, keep going until you reach 9 and then make one extra operation for the carry, right? So when we go from 4 to 5, we will see 5, we will mark it. We'll go to 6, we will mark it. We'll go to 7, we will mark it. We will go to 8, we will mark it. We'll go to 9, we will mark it. Then we will make one extra carry operation and we'll go to 0 and mark it, right? So to get a carry, how many operations will we use? To get carry and see elements from last digit up to P minus 1 and 0. It will take us how many operations? It will take us P minus last digit operations, right? In this case, my last digit was 4 and my P was 10. So it took me how many? It took me 10 minus 4. That is equal to 6 operations, right? So if we count it, we get 1, 2, 3, 4, 5 and 6 operations, right? So it took me 6 operations to see all the numbers from last digit to P minus 1 and then get a carry to 0, right? So after we get a carry to 0, if we move to the first observation, right? When we get a carry, all the numbers from x1 to xn minus 1 will change, right? Up to this point, we were only making changes to xn, right? Because there was no carry. As there was no carry, only xn was changing. But now we have a carry, right? So when we have a carry, numbers from x1 up to xn minus 1 will also change. So it might happen that when numbers from x1 to xn minus 1 change, there might be some new numbers in these n minus 1 numbers, right? So when we take a carry, we have to first compute x1 to xn minus 1 and then update your scene array accordingly, right? So when we get a carry, so now we get a carry, and when we get a carry, numbers from x1 to xn minus 1 will change. And when they change, we have to update scene array, right? So my number was 70924. So I have 70924. And if I get a carry in this will become 0, right? When I get a carry, one will be added here. So I get 70930, right? So I get, this is my x. After carry, this will become x dash, this is equal to 70930. So now if I build the new scene array, this is my scene array. I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I have seen all the elements from 4, 5, 6, 7, 8, 9. I have also seen 0 and I have also seen 2, right? I have also seen 2, right? Yeah. But now I have also seen 3, right? So if you see, we have also seen 3. And this 3 came from x4, right? This is x1, this is x2, x4, x5, right? So now my x4 gave me this 3. It did not come from the last digit, right? My x5 did not give me 3. This 3 came from x4, right? So that's why I was saying, when you like give a carry, your numbers from x1 to xn-1 will change, and they might give you some new numbers, right? So in this case, it gave us a new 3. So firstly, our left block was here. So now if you try to compute the left block, it will move to 3. So this is the 3. It will move to 2 also. So now my left block is up to 2. And my pointer is currently here. My pointer is currently at 0. So currently my pointer is at 0. And my all the elements up to left block are seen, right? So if you think about left block, that is why left block was important. Left block is giving us a boundary that all the elements up to left block are seen. So we just need to apply operations to reach up to left block, right? And there is only one element that is before left block. So we will need one extra operation, right? So now 1 will also be seen. So now all the numbers from 0 to 9 are seen. And it took us total how many operations? 6 operations to get carry. And then 1 operation to reach left block, or you can say get to left block. So if you have to compute the answer, your answer will be how much? Your answer will be just p minus last value. This is to get carry, plus to get to left block. Here my value of left block was 2. So it took me 1 operation, right? So it will be just left minus 1 operations to get to left block. And that is the entire solution, right? So if I have to summarize it once again, I will give a brief summary. If your left block reaches 0, that means all the elements on the left side are seen, so you don't need carry. And answer in this case is just the largest missing value minus your last digit. Otherwise, if you need carry, if you need carry, you will first add number of steps to get carry. To get carry, you will need how many steps or operations? You will get p minus last. And after you get a carry, recompute your x1 to xn minus 1 values. Then recompute your seen array. Then recompute your left block. And then it will take you how many more operations? It will take you left minus 1 operations for left unseen elements. Or you can say to reach left block. So in total, it will take you how many operations? It will take you p minus last plus left minus 1 operations. And that is the entire solution. So if you guys want to see the code for this, here is the code. So I have two variables, n and p. N is the number of digits, p is the base. Then I have a map. This will store the numbers that I have seen so far. So first I will take in the number x and update all the numbers that I have seen v of I. So I'll update seen v of I equal to 1. Then I will calculate the left block, right? So if you see here, I will start from the last digit, right? So I will start from 3 and I will keep going left until I am able to see numbers, right? So while the element on my left is seen, I will keep updating my left block. Then I will find the missing element, right? So first of all, my greatest element is p minus 1. So while there is some element that is not seen, I will keep updating. And when I find an element that is not seen, I will update it as missing. So these find my left block and these find my missing element. Then I go to casework. So if my left is equal to 0, that means my left block reaches 0. Then the answer is just missing minus the last element, that is missing minus v of n minus 1. Otherwise, we took a carry. So to take a carry, it took me p minus v of n minus 1 operations. Then my last number became 0. and I took a carry. So I will go through all the numbers from x1 to xn minus 1 and update their values, right? So this is just me updating their values from x1 to xn minus 1. Then I will update my scene value, right? Because when I update values from x1 to xn minus 1, I should see some new values, right? So that's why I am updating my scene values. And in the end, if I'm still left with a carry, because there might be a case that your number is something like, let's say 993, right? So if you get a carry in this becomes 0, you get a carry here, so you get 0, then you get a 1, then you again get a 0, you get a 1, right? So you get a new digit, right? This is the new one. So I also have to think about this. So in the end, if you still have a carry left, you will set scene of 1 is equal to 1, because you get this new one, right? You get this new one. So you also have to update this. And then I will update my left block, right? Because after updating my x1 to xn minus 1 values and updating my scene array, I have to update my left block. So then I will again update the value of my left block. And then the answer is just answer plus equal to left minus 1. The operations required to reach up to the left block. And in the end, I can just print out the answer. So that is the entire solution. So if you guys have some doubts, feel free to join my Discord server. I'll be more than happy to answer your doubts there. And I will see you guys in the next one. Bye-bye.